Hello everyone. Welcome to the second episode of our number series. It's a series. I won't believe that we do have a second episode. I thought I'm gonna give up after the first one, but here we comes the second one. Yay! And let's jump right into questions, shall we? So the first question, we are asked to find the prime power decomposition of three numbers. Well, over here, for each number, you just try to divide all of the prime power if possible until you reach the limit that the prime number is greater than the square root of those numbers. And then you're gonna realize that it's too big and there's no more number there. And that's how you find those numbers. And number two, you just apply similar process. And let's take a look at the question number 3 over here. And Taglia claimed that the sum of those geometric series, they are alternating between primes and composite. Well, if we do look at the first few ones, it is true, but as we goes on and not very far, we're gonna realize this is not right. So he is going to assume that the first, the third, and the fifth and seventh, it goes on, they should be prime based on the first few patterns that we have observed. But we realize that the seventh term, which is equals to this over here, is actually a composite number, which contradicts the series over here. And question number 4, de Bouville, 1509, claims that one or both of those numbers are primes for all of n greater than or equals to 1. Well, first we're gonna realize that those numbers, they are odd numbers, which means they cannot be multiple of 2. And also, they are the multiple plus 1 and minus 1, which means they are also not going to be multiple of 3 or 6. Because the nearest multiple of 6 for this, as an example, is 6n. And the next one is going to be 6n plus 6. And this lies in between, which means this is definitely not a multiple of 6. And similar reasons applies for this one, which means 2 and 3, they are not going to be multiple of. That's why it seems very contrived that this is true. But, well, we're gonna establish that if n has form of this, then 6n plus 1 is always a multiple of 7. And if n 5k plus 1, then 6n minus 1 is always a multiple of 5. Well, if you want to try why this is true, you sub in those expression of k into n, you're gonna always find that this is multiple of 7 and 5. And you combine of those two, we got this expression, and we try n equals to 36, and this gives us a composite number, or two composite number actually, and which contradict the theory. If you just take the 1 over here and assume k equals to 0, you're gonna get 7 and 5, which are prime number. They are the first multiple of 5 and 7. So, question number 5. If n is a square, then each exponent in the prime power decomposition should be even. Well, this is very intuitive. This is the number and this is the square root. And yeah, that's why it should be even. And the question 6 is just the other way around. You're gonna prove the opposite. And this should not give you too much trouble to believe that. I hope so. And yeah, let's take a look at question 7. So finding the smallest number which is divisible by 2 and 3, which is simultaneously a square and a fifth power. So in order to be divisible of 2 and 3, we're gonna have 2 and 3 to be the base. And to be a square, the exponent should have a factor of 2. To be a fifth power, the exponent should have a factor of 5, which we simplify a little bit, we get 6 to the power of 10. Let's take a look at question number 8. If D is a divisor of A and B, does that follows D is divisible to both A and B? Well, obviously no, because some of the factor of D belongs to A and some of them may belongs to B. For example, when A equals to 2, B equals to 3, and D equals to 6, we're gonna realize that the product of AB is equal to 6, which is a multiple of 6, while individually A and B, they cannot divide the number D over here. Well, this should be very straightforward. And let's take a look at question number 9. Is it possible to for a prime number P to divide both n and n plus 1? Earlier in the chapter number 1, we already know that n and n plus 1, they do not share any factors. Well, in case you forget, I'm gonna repeat this once more. So if they do share kind of factor, let's say D over here, we can rewrite the, sorry, here, I made a mistake, here should be minus here. We can rewrite n plus 1 minus n to this expression. We divide D for both this and multiply the D outside. We should not change the value, and n plus 1 minus n should be equals to 1. Since this should be an integer, this also an integer if this is true, then we're gonna know that D is a factor of 1, which means D could only be 1. That's why they don't share any factor, which means they cannot be both divisible by any number other than 1, which means the question 9 is not true. It's wrong. And question 10, prove that n times n plus 1 is never a square for n is greater than 0. So, we're gonna test the nearest square. So, the lower square, which is equals to n squared, and the upper square, which is n plus 1 squared. And this expression lies in between, and those two are consecutive squares. And that means there's no square in between those two, which means this thing is lie between. It cannot be a square. Well, very simple to understand, right? And question 11, verify this. I mean, just multiply this out, and I put this in my calculator, and it gives the result that I am expecting. This is true. And 11b, is this possible for other a and b to have this expression here? So for this question, we already know that based off of this, 2 to the power of 5 times a to the power of b equals to 25ab. This is digit, not 25 times ab, no. So we already know that from this should be a multiple of 32, which gives us 3 different options, here and here and here. Since 2592 is already appear in A, we are gonna find if there's any other in A and B. So we are not going to consider this. we are only going to consider this and this. But if you resubbing the value of A and B back to those original equation, we're gonna realize that they don't equal, which means there's no other possible numbers. Okay, let's see. Question 12. Let P to be the least prime factor for n where n is composite. Prove that if P is greater than n to the power of 1/3, then n divided by P is prime. So we know that in order for n divided by P to be composite, n should have at least 3 prime factors, because a 3 prime factor, I apologize, because if it only have 1 or 2 factor, after it divides P, which is also one of the prime factor, it's going to have 1 or 0 factor left to be considered, and that's going to be prime, which means we're gonna have at least 3 prime factors if we expand the product expression. But in order to minimize n to the power of 1/3, for any given power or for any given number of P, the minimum happens when n equals to the cube of P. But we're gonna realize this is not good enough for P is greater than n to the power of 1/3. So, which means this is impossible. That means n divided by P has to be a prime. So let's take a look at question 13. True or false, if PQ both divide n, each is greater than n to the power of 1/4, then n divided by PQ is prime. It's false. Consider this. N has form like this. F1 and F2, they are very small, and F3 and F4, they are very big. Well, let's see this example. Those 2 big factors, they are both greater than n to the power of 1/4. And when divided by this equals to 4, which is a composite number. So it is not true that n divided by PQ is always a prime. This is false. And question 14, this is a very interesting one. So for those of you maybe in grade 9 or grade 10, you may not know the geometric series, but it's alright. You will learn that when you go to the higher level of math. If you don't get it, it's fine. And all you need to know is that if n equals to a times b has a form like this, then we're gonna know that this is equal to this expression. If you try to multiply this to every single one of the terms over here, you're gonna cancel out a lot of different terms and get this the front end and the back end. You just divide this expression to every single one of these terms, and you're gonna cancel out all the things in the middle. And if you have any number like this, you're gonna find this and this is always to be a factor, which is very interesting. And number 15, if this 2 to the power of n minus 1 is a composite, does that mean that n is also composite? So n equals to 11. 11 is a prime, but this number here is a composite. That means that N doesn't necessarily have to be a composite, it could be a prime. And that concludes our section of number series, and thank you for watching the video. And hopefully we will see the next video coming soon. And goodbye everyone. Thank you for watching.